Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 554 brick wall. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes before jumping into the solution. Let's get right into it. What problem is asking? That you need to draw a line that passes through the minimum number of bricks, and bricks are 1 unit in height, but their length is different. They are 1 unit height, but their length is different, and they are in n rows. What you are asked is that you need to draw a line that passes through the minimum bricks. So let's see an example and try to understand. Yeah, as you can see, it is just this test case image, this test case image. What you can see is that while, let me change the pen color. Which color would be this would be more visible. While making this line, you can see it passed this and this one, and also in the problem it is written that if these are two, for example, bricks, if the line passes through this, it doesn't count any of the bricks. So that's what happened in this case. In this case, these 6 bricks are not counted as intersected. You know the reason why, written in the problem. So how to approach this problem? The very important question, how to approach this. We have understood this much, that this is that, but how to compute that using the programming language? You can see, if we write this 3 1 2 1 3 2 2 4 3 1 2, what you can see is, if we make our problem something like that we are concerned with this the joining of two bricks, isn't it or not? Our major concern is this position. We need to find this position, because why? Because when the line passes through this, it doesn't intersect any of the blocks or the bricks. So the whole focus should be on this, we have to get this position at maximum. We have to draw a line at this position where bricks are intersected as much as less possible. We need this position. Now problem boils down to this. We need to find this position. We can find this position how? Basically, if we draw this, I am drawing this structure in bricks. This is one length, this is two length, and another one was two, again two length, again two length, and again one length. Am I right? Now, yeah, 0 1 2 3 4. Did it strike something? Did it strike something? We have our edge at 1, we have at edge 2, we have edge at 3. We are not counting this and also not this, only these edges. We have edge at 1, not edge, the meeting point of two bricks at 1. 2 3. Isn't it what we required, that we want this joint, this joint? Now the problem boils down to this: count the joints. Count the joints. According to how? We have 1 index, 2 index, 3 index. We just have to count how many are present at 1 index, at 1th position. How many have this? At 2th position, how many have this? At 3th position, how many have this? Now the maximum we have this, in whichever index we have maximum of this, we got our answer. Because how? If maximum, let me draw it again. If maximum are passed like this, and we have this much row n, so how many blocks did we crossed? N minus 3 in this case, in this particular case. Isn't it? Isn't it or not? That the problem boils down to this index, the index where these blocks joint. Also, I've converted that index into this, as this is also unit 2. Also, this is unit 2. But if you write it like on a number line, you can see for yourself that at 1th index we find this, at this index we find this, at that index we find that. 3 meeting points. Now you get it, how to count the frequency of these position at the certain index using HashMap. I hope I was able to make the intuition very clear and reproducible in the interview. So let's get into the algo. Our algo is very basic, that we will fill the HashMap. Map would be like int comma int. This will be the index. This will be the frequency of this at this particular index. And another thing would be iterate that HashMap and find the maximum, find the max frequency. And at last, what to do? Whatever this, the number of rows, n is number of rows minus this, the thing which we found, let's call it x. We have our answer. Let's try to take this. It will be a hell long example. 2 2 1. Three, two, one. Not 3 1 2. 3 1 2. 3 1 2. 3 1 2. 1 3 2 2 4. Let me drag this test case over here. Why am I scrolling up and down again and again? Copy. That's it. Now it's clear. 1 3 2 2 4 3 1 2. Now we have to calculate every index. So let's see how we gonna calculate is. We take idx 0 for every row. We will take idx 0. Okay, let's begin. At index 1, At index 1 we have 1. Now 1 plus 2, it's 3. At index 3, what we will have at index 3, we have 1, and 3 plus 2, 5. 5 at index 5, we have, what do we have? 1. 5, 6 at index 6, what we have? 1. We will not consider this one, sixth index. We'll see. Again, index is 0. We calculate this. 3. It's changed to 2, 4. A new entry formed. 4. 4 plus 2, 6. Now 6 is 2. 6 is 2. My bad, I have just taken 6. 6 is the last one. We are not taking 6. 6, we are not taking 6, my bad. I just forgot myself. We are not taking 6. That's why I even looked at the code that, yeah, 6. No, we are not taking 6. Again the next row. 1, 2, 1 plus 3, 4, 4, it's now 2, and 4 plus 2, 6, and last we are not taking, we are taking up to this much only. 2, 2, 2, 1, 2 plus 4. No, we are also not taking this. 3, 3 is 2, 3, 1, no, 4, 3, 6, we are not taking this. The maximum we are getting is 3. How many rows we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. We have 6 rows. We are getting 3 max. Did I just messed up somewhere? 1, 1, 1 plus 2, 3, 3 plus 2, 5, 1. We are not taking this. 3, 3 goes to 2, 4. It's 4 is also 2. We are not taking this. 1, it's 2. 1 plus 3, 4. It's 3. And 4, we are not taking this. 2. 2 plus 4, 6, 3. How many times did we got 3? 3, 3, 3. I just forgot to write the last test case, that's why. 1, it's 3. 1 plus 3, 4. 4, it's now to 4. 4 plus 1, 5. 5, it's now 2. The maximum that we are getting is 4. 4 minus 6, it's 2. And again I am repeating that we are not taking that last, because we don't want this. Here it's nothing. We want bricks in between the bricks. So I just messed up over here. I was saying that, but I did write it. We will not take that. And also for every row we will do a reset of the index. It's like a prefix. You are storing prefix in the hash map. I just build a whole story over it so that you can have a intuition as well as a reproducible logic at the interview. So let's see the code. Let me zoom it a bit. Yeah, we are number of rows, max brick 0, index idx as discussed, the unordered map, edge frequency as name suggests, just iterating over it. For every row, index is reset to 0, prefix sum, or the edge and putting that inside the frequency map, and after that just calculating the max, as it's a map, not a normal vector, it's a container. So that's why it.second, because map has two entries. First is the key, second is the value. So that's much very understandable again. And here what we are doing, as discussed, maximum bricks minus the number of bricks, you get the minimum bricks that are intersected, or the bricks that are intersected. You can even think as the number of bricks that are not intersected minus the total rows. You will get the bricks that are intersected. So you can even think like that. So let's submit it and see if it is running or not. Yeah, it is running quite fast. So I hope I was able to make you understand the intuition and you did learn something. If you did, consider subscribing to my channel, liking this video, and you have to do what you have to do. So keep grinding, and you guys are awesome. See you in the next one. Bye bye.